Alright, today we are going to talk about this triangle, and it doesn't look particularly fancy, but it is a very, very special triangle in the world of mathematics. It's a right angle triangle, I know that because of the little square symbol in the bottom corner here to represent 90 degrees or a right angle. We know from previous videos that we can name them with capital letters at each vertice, which is the pointy bit at the end. Each one of these is a vertex, the plural is vertices. And I know I can name the sides with the corresponding little letter. So opposite vertex A is side A. Opposite vertex B is side B. Now if I was to measure these out in this particular triangle, I might have 3 centimeters for B, 4 for A, and it works out to be 5 for C. Let's work out and have a bit of an explore with that, see why that's so important. So I'm going to take my 3 centimeters here, and I'm going to draw them as squares, 3 little squares here. I'm going to do the same for A. Here are my 4 centimeter squares, and for C it works out there are 5 centimeter squares. Now I'm going to take it one step further. I'm going to square this side, so 3 along here and 3 out this way creates a square that is 3 by 3. Let's do the same with side A. I'm going to get a square now that will be 4 by 4. And if I do side C, I get a square that's 5 by 5. Alright, we're going to play with this now. First of all, I'm going to work out how many boxes do I have here. Well, if I do 3 squared, I can see that this is length B. If I square it, I get B squared, which in this case is 9 orange boxes. Right, 3 rows by 3 columns, 3 times 3 gives me 9. Let's have a look down here at the A side. This is the length A, this is the length A. When I multiply them together, A squared gives me 16 blue boxes. Now, here's where the magic happens. I'm going to transfer these colored boxes over to my C square. So I'm going to take these 9 orange boxes first of all, and you'll see they fill 9 places over here. I'm going to take these 8 boxes on the right hand side here and slot them into 8 spots on my C. I've got 6 places available here, so let's take those 6, and you'll see I've got 2 spaces left, which, hey, what do you know? I've got 2 boxes left in my original colored boxes here for A. So you'll see the exact same number of orange and blue boxes added together filled exactly the 25 boxes that I've got on side C. So if I do C squared, you'll see it's 5 by 5 is 25 boxes. So I had A squared down here, B squared here, and now C squared, and they fill the space exactly. So what does that mean? A squared plus the B squared together adds to give me my C squared. And this very famous formula is what we call Pythagoras theorem. A squared plus B squared equals C squared. Let's put some numbers in and just see that it actually works. We know in this case our length of side A was 4, side B was 3, and side C was 5. So I'm going to replace the A, B, and the C with those numbers, 4, 3, and 5. Calculate these numbers out. 4 squared is 16, 3 squared is 9, and 5 squared is 25. Now have a look, is this true? Does 16 plus 9 equal 25? Yes, it does. And we've just discovered Pythagoras theorem. A squared plus B squared equals C squared. We're going to do some more work with that in a future video about how we can apply that to any right angled triangle. Well done.